Hello and welcome to another one of D's ADD videos. Today we're going to be discussing the concept of inequalities. At first we're going to start off with a little introduction. When we're dealing with inequalities, what we're referring to is the use of these symbols here. They're called Boolean symbols. And basically they each have their own meaning, which most of you are pretty familiar with by now. The first symbol we're going to look at is less than. The point of the symbol usually points to the smaller value, and the bigger part points to the bigger value. So 4 is less than 6, negative 6 is less than negative 2, negative 12 is less than negative 8. Alright, so we also might see the x is less than negative 1. We have a variable. However, we got to this point, we solve some equation, we get to this inequality. Well, the way we would indicate that, because there's only one variable, we only do the horizontal number line. And we use an open dot because there's no equal sign, and all values of x are smaller than this negative 1. If we were to look at it in interval notation, it would start at negative infinity. We can never use a bracket with negative infinity, you can never include it, comma, negative 1. And we use a parentheses here because it's an open dot, because there's no equal sign here. Alright? Most of you should be pretty familiar with all this stuff. The counterpart to this, of course, is just greater than. And with greater than, we're talking about being bigger than, as the name implies. So 7 is bigger than 5, negative 2 is greater than 1, negative 3 is greater than negative 8. If we had a possible set of solutions with our inequality to represent this graphically, what we would do is we would draw a number line with the open dot again because there's no equal sign, and we would shade our arrow to the right because this is saying x is larger than 1. And if we were to do interval notation, we would use a parentheses again because it's an open dot because there's no equality, and it would go to infinity. Alright? Again, the infinite numbers, always a parentheses, never a bracket. So less than or equal to is just pretty much the same thing as less than. The only difference is that we are going to include the actual number as a possible choice in our comparison. So these are just statements. 4 is less than or equal to 6. Yes, 4 is less than or equal to 6. I could have had a 6 here is less than or equal to 6 and still would be a true statement. Alright? You're usually going to see these not like this. Maybe if you're doing computer science and programming stuff. But as far as algebra is concerned, what we're going to be doing is we're going to be solving. So typically what you'll see is this in the form of x is less than or equal to 5 or some number when you've solved some inequality. Now the difference here is we're going to get a closed dot because of the equality, and it's going to be shaded to the left. So the main difference was a closed dot, and because we have a closed dot, we're going to have a bracket being used because of the equal sign. Alright, so it's going to be from negative infinity to 5. Again, the infinites never get a bracket, always parentheses. Greater than or equal to is the same premise as greater than, but the only difference is in our comparison we can include the original point. So 14 is greater than or equal to 6, or 14 could be greater than or equal to 14. Comparisons would still be valid or true statements. Typically, we're going to encounter these when having solved an inequality and having this as a solution. And the way we would graph this is again on a number line, no y, it's just an x. And we would get a closed dot here because of the equal sign, and the 0 would get a bracket also because of the equal sign. And we would shade to the right because x is larger than 0. Alright? These are the basics of inequality rules, just an introduction. Alright, so when we're solving inequalities, we might come across some linear inequalities. Basically, that means that the highest power of x is 1. And when you solve them like you would any equation. The only difference you will have to do is you will have to change the direction of your inequality if one of two things happens. If you multiply or divide by a negative number, or if you take the reciprocal of both sides. These are the two scenarios in which you have to change the direction of your inequality. So this will become this, or that will become that. This will become this, or that will become that. All right? And under these two scenarios. But other than that, you're solving just like it was an equation. Another place you might come across inequalities is when dealing with absolute values. And when we're dealing with absolute values, you're going to create two inequalities and then solve the inequalities. So, for example, if you had something that looked like this, absolute value of whatever is inside is less than, make sure this is a positive number. We'll go over the scenarios in which, for instance, if there's a negative sign here, there'd be no solution because by definition, a positive number is what you get from absolute value, and it can never be smaller than a negative number. Okay, we'll go through that in examples. But for now, just if you have one of these scenarios, what you're going to do is you're going to set up two inequalities. One is going to be where you're going to be less than the positive number with a positive sign here. But the second one is going to have either a negative sign on this side, all right, or you can have a negative sign on this side with this flipped in the other direction. What I recommend people do is just keep everything pretty much the same and make as minimal changes as you have to. Just stick the negative sign there. And then you can either distribute it through and solve that way, or if you want to divide right away and change the direction of the inequality. Don't forget that part, okay? You might see some scenarios that are a little bit more complex than just a linear inequality or linear absolute value. In those scenarios, you're going to have to use this technique called sign analysis. When do I use it? Well, if I have a power of x greater than 1 and one of these symbols, then I use sign analysis, okay? You need to make sure that on the other side of the symbol is always a 0 when you're doing a sign analysis. I'm going to dedicate a whole other video to this concept. I'm just putting it out there so you don't panic if you don't get the right answer and you're solving a quadratic like x squared one. Or the other scenario in which you have to use sign analysis is if you have a fraction and one of these symbols, all right? So however you get to the inequality, whether it's a domain question, absolute value question, or you're just given an inequality to solve, you have to know when to use the sign analysis, when to change the direction of the signs. All this comes with practice. Make sure you check out the beginner, intermediate, and advanced videos. Also check out the videos for sign analysis. That's a whole different topic that I'm going to do a concept video for, as well as example videos. Practice, practice, practice is always the key. Thanks for watching. Have a great day.